Hey everybody. So today we're going to start up number 35. It's going to be this video will be just on this one problem because it's a four-parter. So we're almost done with this test though. So if this is your first time watching, there is a description, or a link in the description that brings you to the Pearson website where you can take this test digitally. So the idea is that you'll have taken this test before, or at least just tried this problem before, then watch this video and it'll walk you through it. Okay, so if you haven't tried this yet, pause this, click on the link, try the problem, and then come back and watch this, okay? And there's also a PDF you can download and print if you're not one of my students. Okay, let's get right to it. So this question has four parts. At the beginning of the year, Samantha deposits $1,000 into a savings account that pays 2.5% interest. She does not deposit money into or withdraw money from the account for 1 year. Part A, what is the interest rate expressed as a decimal? Okay, so, so the interest rate is right here. It's 2.5%. Right? So to convert that to a decimal, you just move this decimal 2 spaces to the left. So it's going to go here. So it would be 0, 0, 2, 5. It's decimal. Okay? And that's it. 0, 0, 2, 5. So you just move the decimal 2 spaces to the left. That's a pretty straightforward one. Most of us should remember that. If not, hopefully this jogs the memory. Okay? All right. Let's look at part B. Now this is a lot to take in, so let me fix the focus here. This can be a little intimidating when you first read this. So essentially this is the formula that we're going to be using. This formula can be used to calculate the total amount of money, including interest, into an account over time for a deposit of $1,000. So this is the deposit amount, and in this formula, let me zoom in a little more so you can see this a little better. This is the formula that we would use. Okay, in the formula, the variables A, R, and T, and N are defined as follows. A is the amount of money in the savings account after T years. This is what we get, right? This is what's in there, rather. R is the interest rate as a decimal. T is the amount of time in years the money is invested. And N is the number of times the interest is compounded in 1 year. Okay. What is the amount of money, in dollars, in Samantha's savings account at the end of 1 year if the interest is compounded annually once per year? Show or explain how you got your answer. Okay, so we're going to take this formula and we're going to plug some stuff in. The first thing we need to plug in is going to be the interest rate as a well, not first thing, but we have to use this interest rate as a decimal because it's Samantha we're talking about here. It's still Samantha we're talking about here. So the R is going to be 0.025. Okay. It says in 1 year, so T is going to be 1. And then N is the number of times it's compounded annually. It says once per year, so that's going to be 1 as well. So these are the values we're going to plug into this formula. So A equals 1,000, parentheses, I'm going to sneeze and pause it. Ooh, good thing that sneeze was not on mic because that was loud. 1 plus, now our R is going to be this. Okay. Our N is 1. Then our N is, I'm going to zoom in a little more so you can see. Our N is 1, and our T is 1. Okay? So now we just simplify this. Actually, I'll zoom in a little more on this side. Okay? So you would be using there's a calculator that's available in this problem. It's on the upper top part of the screen. You could use that. I'm going to just use this calculator while we're here. So, okay, let's follow our order of operations. So we'll do exponents first. Sorry, parentheses first. So inside the parentheses, we do this division. So this divided by 1 is just going to be 0.025. So 1 plus 25 to 1,000. So and 1 times 1. So this would be 1,000 times 1.025. 1 times 1. Let's do that. That's going to be 1. 1.025. That's 1. So anything to the 1 power is just itself, so it'll just be itself. So we're multiplying this by 1,000, and we're just going to move this decimal 3 spaces because that's how many zeros there are, so it's going to be 1,025. So this is how much money would be in Amanda's account after that 1 year. Or Samantha's, not Amanda's, sorry, Samantha's. Okay, let's turn the page. Part C. Samantha deposits $1,000 into a new savings account. Samantha apparently has a lot of money. The new savings account pays 3% interest, compounded semi-annually, twice per year. She does not deposit money into or withdraw money from the account for a year and a half. write an equation that can be used to determine the amount of money in dollars in the new savings account at the end of a year and a half. So we're just going to write the equation. We're not going to solve it yet. We're just going to write it out. So I'm going to write the base equation first. So A equals 1,000 and 1 plus R over N times NT, right? So our R is going to be 3%, but as a decimal, so it's going to be 0.03. Our N in this case is going to be, let's see, 2. Yep, it's twice per year. It's semi-annually, right? N is the number of times you do it per year. And T is the time that goes by, so it's going to be 1.5. Okay, so those are our values. We're just going to plug those in. So 1,000, and then 1 plus R is going to be 0.03 over N, which is 2, and then N is 2 times 1.5. Okay, so that's it. And I believe the fourth part, I think we have to simplify this, I believe. Use the equation you wrote in part C. Let's zoom out a little more. And determine the amount of money in dollars, excuse me, in Samantha's new savings account at the end of a year and a half. Show or explain how you got your answer. So yeah, that's exactly what we're going to do. We're going to solve this. We'll simplify it rather. What am I doing? 1,000 and 1 plus 0.3. 2 and 2 times 1.5. So at this point now it just becomes an order of operations problem, right? So let's do the stuff in the parentheses first. So we're going to do that. So 1,000 and 1 plus 0.015 because 300 divided by 2 is 15 thousandths. And then 2 times 1.5. So 1 plus this would be 1.015. 1,000. There we go. And 2 times 1.5. Okay, so 2 times 1.5 would be 3. So 1.015. 3. Okay, so now we would just use, this is where I'd use the calculator on the test, because I don't want to do that by hand at all. So I'm just going to use this calculator so you guys can see. And raise that to the 3rd power. So we get that weird number. We're going to multiply that by 1,000. Okay, so we're going to get $1,045.60. We're going to round that to 68 cents. And that's it. Okay, pretty straightforward. All right, so let's just do a quick recap. Part A was just asking you to convert this percent to a decimal. Pretty straightforward. You should all be able to do that. Part B, we have to plug it into this formula and solve. So as long as you get like the first 2 parts right of this problem, like I've said before, if you can get 2 out of 4 parts of a multi-part problem correct, you're very statistically likely to pass the MCAS. So you obviously want to try to get all 4, but as long as you get the first 2, you're usually going to be in really good shape. Here we have to write the formula out, but not solve it with the new information. And then part D, we just solve that formula or simplify it. All right, hopefully that's helpful. Talk to you guys soon.